Today we will going to discuss the differences between the fixed beam and the simple supported beam. It's a very important fundamental videos that I am going to make, which will help us to understand the basic differences between two. Apart from that, it is very important, before going to the analysis of the fixed beam, we have to know the basic features of it. Let's start. Fixed beam versus simply supported beam. Okay, let's draw two beam first. In the left side I am going to draw the fixed beam. Okay, if it is a fixed beam, it's a fixed beam. Okay, you can see that it's a fixed beam, and here it's your simple supported beam. Here is a hinge support and here is a roller support. Okay, and I put the load W in the both occasion at the center of the beam. At the center of the beam, the magnitude of W in the both occasion is same. And now the thing is that if there is a load, the beam will deflect. In case of the simple supported beam, the beam deflection is like that way. Okay, but when you are talking about the fixed beam, the deflection will be this kind of. So if you are going to measure the how much deflection is occurred in the simple supported beam, that is say YC. Okay, but in case I am putting YC dash, and if you talking about the slope is, if you draw a tangent from this with the fixed beam, the angle made, that is theta. If it is A, then it will be the theta A, and if it is B, that will be the theta B. It's its slope. Okay, but in that case you can see there is a no deflection start from the joint, so there is a slope is 0. If it is A, if it is V, then theta A equal to 0 and theta V also will be the 0. Theta A and theta V are the slope of the two beam. Now the thing is that if the basic differences between two, you know that deflection is a failure mode of the beam. In case of simple supported beam, you see the value of YC is much greater than value of YC dash. Hence YC dash is the deflection amount of the fixed beam. So we are going to think about the fixed beam in every circumstances to reduce the amount of deflection. Now you may ask why the deflection is the minimum in case of fixed beam, because you can see there is A and B, there will be a moment, you can see this is an anti-clockwise moment and it's a clockwise moment applied. This moment, when beam is going to deflect as a simple supported beam, this moment will put pressure from the bottom to the top, so the deflection will be minimized. Okay, so you understood that why deflection is minimum and why we going to the fixed beam. And if you want to realize the example of a fixed beam, then you have to see on your floor. Every beam have you seen in your room, that is the fixed beam. Now another difference is we know that statically, in case of statics, you know there is a three equation: summation x equal to 0, summation y equal to 0, and summation m equal to 0. Summation x equal to 0 means summation of all horizontal forces, that means algebraic sum will be 0. In case of summation y equal to 0, summation of all vertical forces is 0, and summation of m equal to 0. In case of fixed beam, the unknown parameters is Ra and Rb, and you have three equations. So from three equations, you know that three unknown can be resolved. So by using these three equations, you can solve out Ra and Rb very easily. But when you are going to, so it's known as statically determinate, which is statically determinate structure. But when you going to the fixed beam, you can see there is a four unknown, that is Ra, Rb, Ma moment at A, Mb moment at B, but you have only the three equations. So by using the three equation, you cannot resolve the four unknown parameters. So fixed beam is a statically indeterminate structure. Okay, thank you.